Well, welcome to our first lesson in Unit 2, and this lesson is on relations and functions. Your learning targets for this lesson are to be able to analyze and graph relations, to be able to distinguish between a relation and a function, and to understand function notation and using that to represent equations. So first of all, let's do a little bit of review of our Cartesian coordinate system. And in the Cartesian coordinate system, we have a two-dimensional plane, and it is broken into 4 quadrants and 2 axes. The 2 axes break it into the 4 quadrants, and those 4 quadrants are labeled counterclockwise, with the first one being quadrant 1, and then 2, 3, and 4, and it goes around in a counterclockwise direction. All the points in the coordinate plane are represented as ordered pairs, and we always have the x-coordinate first, followed by the y-coordinate. Now the x-coordinate is a left or right direction. Right is positive, left is negative. The y-coordinate, up is positive and down is negative. So when we talk about the domain of a relation or a function, we are talking about all the sets, the set of all x values or inputs in the relation or function. And the range is then the set of all the y values or all the outputs. So when you think of the domain, just think of all the x variables, and the range is all the y variables. So a relation is basically any set of ordered pairs. So any ordered pairs at all is always a relation. So everything is a relation. And a function is a special kind of a relation where each element in the domain is paired with exactly one element in the range. So over here I have a couple of different examples. So in the first example on the top here, in order to be a function, every element in the domain is paired with exactly one element in the range. Well, we can see that -3 is paired with 2 elements in the range, so this is not a function. Okay, the second example, each element goes to one place. That is a function. And the third one is also a function. So we can have two different things going to the same place in the range, but we can't have anything in the domain going to 2 places. So a one-to-one function is a special kind of function where every element in the range is paired with exactly one element in the domain. So this third example, not only is it a function, but it's a one-to-one function. Now the second function is not one-to-one because 5 goes to 2 places. And this first one, as I said before, is not a function at all. In this example, it says state the domain and range of the relation represented by the graph. Well, we have 5 different ordered pairs. So the domain will be the set of all of the x-coordinates. So if we just take the x-coordinate for each of these points, that will give us our domain. So we have -4, -1, 0, 2, and 3. Those are our domain elements. And then very similarly, the range will be all the y-coordinates, -4, -3, -2, and +3. A relation whose domain consists of individual points is called discrete. So this is an example of a discrete relation or a discrete function. A relation whose domain consists of an infinite number of elements in the domain and graphs as a line or smooth curve is called continuous. So any kind of a line, when we have arrows on the end, is continuous. But when we just have points, that's called discrete. Relations and functions can be represented by equations. Here's an example of a linear equation. X always represents the inputs or the domain, and Y represents the outputs or the range. So there's an infinite number of inputs and outputs, so the graph is continuous. We can put anything we want in for X, and we'll get just about anything out. So we can choose our values for X and then calculate the Y values, and then we can graph those ordered pairs. So if I put in a 0 for X, I get out a 3. If I put in a 1 for X, I get out a 5. And if I put in a -1, I get out a 1. Then when we go ahead and plot those 3 points, we can plot those on a graph and connect them. And we know that there are values in between each of these values. Between 0 and 1, we could put fractions or decimals in there and get out fractions and decimals in between. So this is a continuous function, okay? So here are a couple problems. Go ahead and pause the video here, pick values for x and calculate your values for y, and then I want you to graph the equation and determine whether or not it's a function. All right, I hope you took some time to do that. This first one on the left, if I pick x values that I've given you here, the corresponding y values are given here. So for x, if I pick -2 and then I add 2, I get a 0, and the square root of 0 is 0, and so on and so forth. So then I can go ahead and plot those points in the graph, and your graph should look something like this. So now you needed to decide whether or not that is a function, and this one is not a function because you can see that the value +2 and +6 goes two different places. So this one is not a function, and I don't know if I wrote that in there anywhere. I don't think I did. So that is not a function. Letter B, if you picked values for x that I gave you here and calculate the corresponding y values, you would get these values. And then graphing that function, that one looks like this. This is called a parabola. This is a quadratic equation. And this is a function, okay, because every x value goes to a different y value. Equations that are functions can be represented using function notation, where we use f of x instead of y. We replace y with, and I wrote how this is read, f of x. So when we have an equation like y equals 3x plus 5, we rewrite that in function notation would be f of x equals 3x plus 5. It means the exact same thing. This is just function notation. So x is called the independent variable. It is independent of anything. We choose values for that. Y is the dependent variable because it depends on what you chose for x. So we can evaluate functions for any value. For example, if we wanted to find f of 2 using the function above, we would take 3 times 2. Instead of an x, we're going to put in a 2, and then add 5. 6 plus 5 is 11. Likewise, we could use anything with variables as well. We could put in 3a. So we would have 3 times 3a plus 5, which is 9a plus 5. Now these are not like terms. The 5 does not have an a, so they do not combine. If we put in an x squared where we see an x, that would be 3 times x squared plus 5. That gives us 3x squared plus 5. That is it for this video on function notation. We will see you next time.